1 minute ago, the James Webb Space Telescope finished analyzing a visitor from beyond our solar system, and what it found has scientists choosing their words with unusual caution. Not because the object is dangerous, but because it is unlike anything that has ever passed through our cosmic neighborhood before, carrying chemistry so strange that researchers are now saying it could rewrite what we think we know about how solar systems, including our own, actually come to exist. Stay with me, because this isn't speculation. This is a real object, tracked by real telescopes, currently speeding through our solar system as you watch this video. Let's start with what this thing actually is. On July 1st of 2025, a survey telescope in Chile called Atlas spotted a fast-moving object streaking through the outer edges of our solar system. Astronomers quickly ran the numbers on its trajectory, and the result was stunning. This object wasn't orbiting our sun, it was just passing through, moving on a path, so steep and so fast that it could only have originated from outside our solar system entirely. It had traveled here from somewhere among the stars. They named it 3II Atlas, and it instantly became only the third interstellar object ever confirmed by astronomers, following two previous visitors detected in 2017 and 2019. Objects like this are exceptionally rare. Most comets and asteroids we observe were born right here, orbiting our sun for billions of years. An interstellar object is something entirely different. It's a fragment of another star system, flung out into the galaxy long ago, drifting through the emptiness between stars for what could be millions or even billions of years, until it happened to cross paths with our sun. If you're new to this channel, we cover discoveries exactly like this one every week, real objects, real data, and real mysteries still being solved in real time. So make sure you're subscribed before we go further into this. Once astronomers confirmed what they were looking at, telescopes around the world, and above it, turned their attention toward 3I Atlas. The James Webb Space Telescope got its first detailed look in August of 2025, using its near-infrared spectrograph instrument, a tool capable of breaking down light from the comet into its individual chemical fingerprints. What Webb found immediately stood out. The comet's coma, the glowing cloud of gas and dust surrounding its icy core, contained an extraordinarily high ratio of carbon dioxide compared to water. That might sound like a small technical detail, but to scientists, it was a significant red flag. In comets that formed inside our own solar system, this ratio typically falls within a fairly predictable range. 3I Atlas blew past that range entirely, showing one of the highest carbon dioxide to water ratios ever recorded in any comet, from anywhere. Researchers proposed two possible explanations. Either this comet had been exposed to far more radiation over its lifetime than anything born in our solar system, slowly cooking away its water ice while leaving the carbon dioxide behind, or it formed in a region of its home star system so cold that carbon dioxide froze into ice more easily than water itself, an environment unlike anything found in our own planetary neighborhood. Then, just months later, Webb detected something even stranger. As 3I Atlas made its closest approach to our sun in late October of 2025 and began heating up, Webb's MIRI instrument picked up a clear signature of methane gas venting from the comet. Scientists describe this as unusual because methane requires extremely cold, extremely stable conditions to remain locked inside a comet's ice for potentially billions of years without escaping. Finding it actively outgassing from an object that just crossed such a vast stretch of the galaxy told researchers something important about where this comet came from and how undisturbed its ice had remained since its formation. If a comet from another star system, carrying chemistry frozen in place since before our own sun likely finished forming, sounds like the kind of story that deserves your attention, do me a favor and hit that like button. It genuinely helps this channel keep making videos exactly like this one. But the discovery that really caught scientists off guard came several months later, after the comet had already made its closest pass by the sun and was heading back out into deep space. In December of 2025, researchers pointed Webb at 3I Atlas one more time, hoping to catch it while it was still warm from its solar encounter, its ancient ice actively converting into a bright, easily measurable cloud of gas. This time, Webb measured something scientists hadn't been able to capture before, the ratio of carbon and deuterium, a heavier form of hydrogen, locked inside the comet's material. That ratio turned out to be genuinely unlike anything found in any comet native to our solar system. According to a study published in the journal Nature in June of 2026, this chemical fingerprint points to an object that formed in a distant, extremely cold environment, likely in the outer, frozen edges of another star system entirely, one with fundamentally different conditions than the one that produced Earth, the Sun, and every planet we call home. One of the lead researchers on the project described this moment plainly. explaining that studying interstellar objects like this one represents a major step toward understanding just how common or how rare the specific conditions needed for life might actually be scattered across the galaxy. That's the real weight behind this discovery. 3I Atlas isn't just a curious rock passing through. It's a physical sample of chemistry from another solar system entirely, delivered directly into our own cosmic backyard, without us having to travel a single mile to go get it. Naturally, an object this strange, moving this fast, carrying chemistry this unusual, sparked intense public speculation almost immediately. Some corners of the internet ran wild with theories that 3I Atlas might not be a natural object at all, pointing to its unusually high carbon dioxide content and its surprising methane signature as evidence of something artificial. NASA and the overwhelming majority of astronomers studying the object have been clear and consistent in their response. Every single measurement collected so far, its chemical composition, its behavior as it warmed near the sun, its outgassing patterns, is fully consistent with a natural comet, just one, that formed under conditions very different from anything in our own solar system. There is no evidence, none, supporting an artificial origin. What makes 3I Atlas remarkable isn't that it defies natural explanation. It's that it gives scientists direct physical proof that other star systems can produce chemistry radically different from our own. That's really the warning buried inside this discovery, if you want to call it that. Not a warning of danger, because 3I Atlas poses absolutely no threat to Earth, and never did. It passed through our solar system on a trajectory that kept it a safe distance away the entire time, and it is now speeding back out into interstellar space, never to return. The real warning is a quieter, more unsettling one, aimed directly at how confident scientists have historically been about the assumptions baked into our models of how planetary systems form. For decades, much of what we understood about comet formation, planetary chemistry, and the ingredients available for life came almost entirely from studying objects native to our own solar system, because that was the only sample size available. 3I Atlas just handed scientists a second data point, and it didn't match the first one. If a second interstellar visitor shows similarly unusual chemistry when it eventually arrives, and astronomers fully expect more interstellar objects to be detected. As survey telescopes grow more sensitive in the coming years, it would suggest that the chemical diversity between star systems across the galaxy is far greater than anything current models account for. Researchers are already tracking where 3I Atlas goes next. As it continues moving away from the Sun, it's expected to pass relatively close to Jupiter in March of 2026, an encounter that could subtly bend its trajectory before it crosses the orbits of Uranus and Neptune over the following 2 years, finally exiting our solar system for good and disappearing back into interstellar space, carrying its ancient chemistry with it, likely never to be studied by human instruments again. Before it leaves entirely, astronomers are working quickly, using every available telescope, ground-based and space-based, to extract as much data as possible, while the comet is still within reach. Every additional measurement adds another piece to a puzzle that, essentially, began the moment 3I Atlas was first spotted streaking through our solar system, carrying secrets from a star system none of us will ever see directly. It's worth pausing here to appreciate just how much technology had to come together to make this discovery possible at all. Just a decade ago, catching an interstellar object early enough to actually study it in detail would have been extraordinarily difficult. Survey telescopes like Atlas now scan huge portions of the night sky every single night, automatically flagging anything moving in a way that doesn't match the predictable orbits of known asteroids and comets. The moment 3I Atlas was flagged, astronomers around the world had to move fast because interstellar objects like this one don't wait around. They pass through our solar system once, on a trajectory shaped by their approach from deep space, and then they're gone, permanently, back out into the galaxy. That urgency is exactly why so many different instruments were pointed at 3I Atlas in such a short window of time. Beyond Webb, NASA also used its Hubble Space Telescope to help estimate the comet's physical size, while missions like SphereX collected additional infrared data on the organic molecules present in its coma. Even spacecraft not specifically designed to study comets got involved. The Psyche spacecraft managed to capture several observations during its own separate journey through the solar system, and the Lucy spacecraft, on its way to study asteroids near Jupiter, spotted 3I Atlas from roughly 240 million miles away. It became something of a global and even interplanetary team effort, with nearly every major space observatory contributing whatever data it could before the window closed for good. That kind of coordinated response matters, because opportunities like this one are exceptionally rare. Only 3 interstellar objects have ever been confirmed passing through our solar system, spread out across nearly a decade of observation. Nobody knows exactly when the next one will appear, or how much warning astronomers will have once it does. Every measurement collected, from 3i Atlas, while it was still within reach, may end up being irreplaceable data, the only direct sample of another star system's chemistry available to scientists for years, possibly decades to come. It also raises a practical question researchers are now taking seriously. If interstellar objects really do pass through our solar system more often than previously assumed, simply going undetected because older survey telescopes weren't sensitive enough to catch them, then upgrading our early detection systems becomes far more than an academic priority. It becomes the only realistic way to guarantee we get enough advanced notice to actually study the next visitor properly, rather than scrambling to catch fragments of data during its brief, one-time pass through our neighborhood. If a single interstellar visitor can already challenge core assumptions about how planetary systems form, what happens when the next one arrives, and the one after that, as our telescopes get better at spotting them? Are we looking at rare exceptions passing briefly through our neighborhood, or the first real evidence that our own solar system's chemistry is far less typical across the galaxy than we've always assumed? Drop your theory in the comments, and let me know whether you think 3i Atlas is a rare cosmic outlier, or the first sign of something much bigger waiting to be discovered. And if you want to be here the moment the next interstellar visitor gets spotted, hit subscribe, because when it happens, we'll be covering it the moment the data comes in. Somewhere out past Jupiter right now, a fragment of another star system is speeding, silently away from our sun, carrying chemistry older than our own planet, having delivered its warning quietly and without ever meaning to.